In this video, I hope to further explore some facts about the arcsine, arccosine, and arctangent. So I've made several videos today using these three functions, and I found myself saying some things over and over and over, and I realized I probably could make some of the concepts a little more intuitive. So this is what this video is about. So one of the things I said is whenever you take the arcsine and the arctangent, they have something in common, and that whenever you use these two trig functions, we always get an angle. In fact, arcsine means the angle whose sine gives you some ratio of sides. And arctangent, whenever you take the arctangent of an angle, you always get answers either in quadrant 1 or quadrant 4. Another way of saying that is that the outputs of these trig functions, the range of these trig functions, are from negative 90 degrees to positive 90 degrees, or if you're in radians, negative pi over 2 to pi over 2. So keeping things pretty simple, not using a lot of math notation, this is the basic idea that if you plug in a ratio of sides into arcsine or arctangent, you're going to get an angle, right? The output of these functions is the angle, and your angle is going to be between negative 90 degrees and positive 90 degrees. And then in a second we'll talk about arccosine, which is a little bit different. So just to prove this to you, I'm going to use my calculator to evaluate the arcsine arctangent for several values, some positive, some negative. So if you remember the acronym All Students Take Calculus, you'll remember that all trig functions are positive in the first quadrant, meaning sine is positive and tangent is positive. And in the fourth quadrant, the C says that cosine is positive, meaning the other two are negative, meaning that the sine and the tangent are negative in quadrant 4. So this is the deal. If you ever take the arcsine of a positive number, you're going to get an answer between 0 and 90 degrees. If ever you take the arcsine of a negative number, you're going to get an angle between 0 and negative 90. It's going to report the answer down here. Same thing with tangent. Tangent, whenever you take the arctangent on your calculator, again, your answer is going to be between 90 and negative 90. But I can even tell you which. If you're taking the arctangent of a positive number, you're going to get an answer in this region, 0 to 90. If you take the arctangent of a negative number, you're going to get an answer between 0 and negative 90 degrees. So just to show that, take your calculator and just start making up some problems. I'm going to take the, maybe I can move this over a little bit. I'm going to take the arctan of, say, 0.3, and I'm suggesting, since I'm plugging in a positive number, that my answer is going to be between 0 and 90 degrees, and it is about 16.7. And it turns out that if I was to take the inverse tangent of a negative number, let's do negative 0.3, what I'm going to get is the same answer, 16.699, but it's going to be a negative angle because the inverse tangent always gives me answers either between 0 and 90 or 0 and negative 90. The answer is always between 0 and 90 if your input's positive, like we just showed, but the answer will be between 0 and negative 90 if your input is negative. So there you go, you get negative 16.7. There's nothing special about 0.3. I could have done inverse tangent of 5 and got the answer 78 degrees. Again, positive input, inverse tangent gives me an answer between 0 and 90. If I give the inverse tangent a negative input, say negative 5, I'll get an answer between 0 and negative 90. In fact, it's going to be the same number here, except negative. I can make the same argument for sine. Just remember that sine is a little bit more limited. If you remember the sine function, it's a little bit more limited than the tangent. So if you remember the tangent function goes up and down forever, but the sine and cosine function look like this. In fact, here's the sine function. It's more limited in its outputs. It can only go as low as negative 1 and as high as 1. So I got to be careful what numbers I plug in to the inverse sine. I can only ask it to evaluate inverse sine between numbers like negative 1 and 1. So being a little careful, I'm going to see what happens when I take the inverse sine of a positive number like 0.6. Again, whenever you do the inverse sine, you're going to get an answer either in quadrant 1 or quadrant 4. But since I'm plugging in a positive number, I know that my answer is going to be between 0 and 90. And there it is. It's 36. If I was to take the inverse sine of the negative of 0.6, well, sine is never negative in quadrant 1, right? Sine is negative in quadrant 4. So I'm suggesting that the answer is going to be down here in quadrant 4, and it's going to represent the answer between 0 and negative 90. So no big surprise to me when I press enter. I get the same answer I did up here, except negative. So that's how inverse sine and inverse tangent work. But you might be wondering how inverse cosine works. It's almost the same exact argument, except for the domain and range is a little bit different. So for arc cosine, let me label these again: quadrant 1, 2, 3, and 4. The other thing I want you to be able to label is all students take calculus to remember which trig functions are positive and which ones are negative in each of the 4 quadrants. So arc cosine, moving to that one, if you want to talk about arc cosine now, arc cosine, you input a ratio of sides and the output is an angle. So the question is, what kind of angle would you get out if you did the arc cosine? Well, it turns out that for any ratio of sides, arc cosine has infinitely many answers, and we want to know which one would you get if you used your calculator. So the idea is that whenever you do the arc cosine, it always outputs angles in quadrant 1 or quadrant 2. That's a bit different than sine, arc sine, and arc tangent. Arc sine and arc tangent always gave its answers in quadrant 1 or 4. Arc cosine, on the other hand, always reports its angles in quadrant 1 or quadrant 2. So which is it? Which one would it do? Well, it depends on whether you plug in a positive ratio or a negative ratio into arc cosine. So if I was to do, say, the arc cosine of, let's say, positive 0.4, and remember I can only plug numbers in between negative 1 and 1 because the cosine function only goes as low as negative 1 and is only as high as 1. So since the cosine function only outputs numbers between negative 1 and 1, I can only input numbers into the inverse function between negative 1 and 1. Anyway, so sticking between negative 1 and 1, if I was to do the arc cosine of 0.4, you'll see that I should get the same thing except opposite sign if I did the arc cosine of negative 0.4. So what ones am I going to get? Let's look up here. In quadrant 1, we've got the letter A, meaning all trig functions are positive, meaning the cosine function is always positive. So if I was to do this one here, this is the arc cosine, meaning give me the angle whose cosine comes out to be 0.4. Give me the angle whose cosine comes out to be positive. So I would get an answer in quadrant 1, meaning my answer should be between 0 and 90 degrees, and I'll do it in a minute on my calculator and you'll see that. But when I do the arc cosine of negative 0.4, remember what this means. It means give me the angle whose cosine comes out to be negative, meaning give me the angle x whose cosine comes out to be negative 0.4. Well, cosine can't come out negative in quadrant 1, right? But over here it can. The S in all students take calculus says that sine is positive. That's a way of remembering that the cosine and the tangent will come out negative. So if I'm looking for an angle so that the cosine comes out negative, it's not going to happen in quadrant 1, it would happen in quadrant 2. Also quadrant 3, but remember what I said. When you do the arc cosine, you're only going to get one answer on your calculator, and it's going to be an answer between 0 and 180 degrees, either quadrant 1 or quadrant 2. Stick in a positive number, it'll be between 0 and 90, quadrant 1. Stick in a negative number, it'll be a number in quadrant 2, which is between 90 and 180. So when I do this on my calculator, I'm expecting to get an answer, an angle between 90 degrees and 180, an angle in quadrant 2. So at any rate, let's do that. Let's take the calculator, and let's just, I completely made up 0.4, but it's just as good as any. If I take the inverse cosine of 0.4, I'm going to get an angle between 0 and 90. I have no idea what it is. It turns out it's 66 degrees. And then the other angle is going to be, if I switch the question to negative 0.4, the other angle is going to be the same one, same reference angle anyway, except my answer is going to be between 90 and 180. So I'm going to get this answer of 113, and you're going to say, okay, that makes some sense in the fact that it's an answer between 90 and 180. That's consistent with what Mr. Nearing said. But I'm used to these numbers having a relationship. Like in the previous part of the video, the numbers came out to be the same, except one positive, one negative. So what's going on here? Well, what's going on here now is that my first answer was 66 degrees, so that would be right here, which turns out to be the same as my reference angle. And I'm just going to round it for the sake of writing it. It's really 66.4, you know, etc. But when I get the angle here, remember that my reference angle is 66.4, but the actual angle in quadrant 2 is the angle that you get when you start on the positive side of the x-axis, that's this, and rotate counterclockwise until you get here. So the reference angle is 66.4, but the actual angle is not. How would I find the actual angle? Well, it would be 180, that would be all the way here, and then back off 66.4. So for example, if I was to take 180 and subtract off the 66.4, 180, subtract the 66.4, and I'm rounding so it's not going to come out exact. If you want 66.4218, you get the idea, 152, and that's still rounding, but I should get this angle of 113. So when I took the inverse cosine negative 0.4, it's not giving me the reference angle, of course. It's giving me the angle from the positive side of the x-axis to the terminal side there. So it gave me that 113. I'm suggesting that 113 is what you'd get if you took 180 and subtracted off the reference angle here of 66.4. So if that makes sense, hopefully that bridges some concepts for you and you can start making sense of what's going on. So indeed, 180 minus the reference angle gives me that reported angle of 113.57. Anyway, hopefully this helps you through. The idea is that the calculator gives you one answer, and this gives you an idea what kind of answers you are to expect. But because there's infinitely many places where the sign takes on any ratio of sides, you know, given your work within the domain and range restrictions, you know, your calculator can only give one of them, and your job as a human might be to find the other one. So if you watch future videos, you'll see me explaining how you can get from the answer the calculator gives you to suppose, you know, some more answers. So if you watch the part 2 to this video, what I'm going to do is I'm going to do the same exact thing where I take, say, the arc cosine of 0.4, but perhaps give 4 or 5 more answers that work. I'm claiming there's infinitely many and that the calculator is only giving me one of them, the 66.4. How would you find the others? So in another video in a second, I will do that.